This next type is pretty easy too. These are combustion. Combustion just means reaction with oxygen, reaction with O2. And there's two types of combustion that we're going to have. One is a type of synthesis. So something plus O2. It's almost always a metal plus O2, and you just make one compound. The other kind is a hydrocarbon, so something containing carbon, hydrogen, and maybe there's oxygen in it too, and it's combusted, so its products are always going to be water and carbon dioxide. So for all these, all the combustions, you react with oxygen. Those are the two types you can react with, two ways you can react with oxygen. What to look for is something plus oxygen, and then figure out which type. To predict the correct products, well, this guy's easy. If you have a hydrocarbon, you know you're going to make water and carbon dioxide. The trick is you have to know the formula of this hydrocarbon. So you have to know some basic naming. The ones you have to know are going to be meth means 1 carbon, eth means 2, prop for 3, and but for 4. And one way to remember that, my ear peels badly. Meth, eth, prop, but. That'll help you remember the M, E, P, B. And then the rest after that, it makes sense. You have your pent, hex, hept, oct, non. So that's for naming the number of carbons. For bonds, if you have single carbon-carbon bonds only, the name's going to end in A-N-E, ane. If you have double, the name's going to end in ene, if you have any double bond. If you have a triple bond, the name of your thing is going to end in ein. Een, ein. And students have told me they remember the order of that because it's alphabetical. 89. Single, double, triple. Then a couple other things. Alcohols are probably the most common functional group. An alcohol, what's easy for me to remember is that an alcohol has a COH bond in it. Alcohol. So I look for that. There's going to be some others, but maybe we'll do a functional group thing as they come. That's about it. So let's try. So we have ethine. Eth means how many carbons? 2. It has 2 carbons. And ein means it's going to have a triple bond. So I'm going to go ahead and draw it out. And I know carbon makes 1 bond. I know that I'm going to have to add 1 H to each of these. Ooh, that was so bad. Clearly, I didn't calibrate the board first. Okay, so there's ethine. So I could have written C2H2. And I will. C2H2 is burned in air. It's going to react with the oxygen in air. That's the combustion. I know my products are going to be carbon dioxide and water. They always are, with combustion of hydrocarbon. And then I balance. I can see, I'm going to save the oxygen for last because it's alone, so I can do whatever I want to do its coefficients. I've got 2 carbons, so I'll make it so I have 2 carbons there. I have 2 hydrogens, and I have 2 hydrogens, so that's good. But then I'm going to see, we'll go ahead and go straight into this problem. I've got 2 CO2, so there's 4 oxygens right there, and then 5. So I've got 5 oxygens. So I need some coefficient here times 2, that'll give me 5. So it would be 2.5. We won't leave that as a decimal though. I'm going to go ahead and make everything double. So this will be 2 ethines plus 5 O2s to give me 4 CO2s, double that 2. Oops. So 4 CO2s and then 2 waters. And it's good. Okay, so dimethyl ether. Ether is one of those functional groups. Ether is the functional group that goes C-O-C. And then we'll go ahead and make the number of bonds we need. Dimethyl, di means 2, meth means 1 carbon. So there's going to be 2 single carbon groups. Here's carbon, there's carbon. Those are the 2 single carbon groups. I know that carbon makes 4 bonds, so 1 bond will be with oxygen, and I fill the rest in with hydrogens. So there must be 3 hydrogens here, 3 hydrogens there. Okay, that's dimethyl ether. Or I could have written C2H6 C2H6O is dimethyl ether. It's burned in air, so it reacts with O2, and it's going to make carbon dioxide and water. H2O, and then we can balance, saving the oxygen for last. So I want 2 carbons, so I'll put 2 carbons. I want 6 hydrogens, so I'm going to put 3 of these, and you can see I'll have the same problem. Oh, I won't have the same problem. So now I look at oxygens, and I've got 4 oxygens here, 2 times 2, 4, plus 3 more, so I've got 7 oxygens on the right, and then I've got 1 plus some number to give me 7, so I need 6 right here. I'll put a 3 there. So now I've got 3 times 2 is 6, and plus that oxygen, 7 O2s, and the reactants and products. The next one, I have magnesium ribbon as burned in oxygen. See, it's just a synthesis. Magnesium plus, don't forget oxygen's diatomic. Balance the charges. This forms a 2 plus, this forms a 2 minus, so their charges are already balanced, MgO. And then balance the equation. 2 O's on each side, 2 Mg's. For the next one, pure solid phosphorus. White form is burned in air. This is the same, that was also the synthesis problem we saw. So P4 is how phosphorus exists. Oxygen exists as O2. You can remember it's kind of the same thing. Like just like we say all these guys are stable as diatomic, P4 is stable as 4. And the product it makes P4O10, and that's because the phosphorus has to lose its 5 valence electrons to that really negative oxygen. And then balance the reaction. Okay, butanol. But means 4. All tells me it's an alcohol, so I know I'm going to have COH. Okay, and I'm going to have 4 carbons. And then I'll fill in the rest of the bonds that I need to make with hydrogens. So I'll have 2 hydrogens there, 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 and 3 hydrogens on the end. So I'm going to just write the formula to make this neater for myself. So C4, and I can see it's 10 H's because 2, 4, 6, 8, 10. H10O. Okay, C4H10O is burned in air, so that's plus O2. This is combustion of a hydrocarbon, so I know that I'm going to make carbon dioxide and water. Alrighty, so 4 carbons, we'll put a 4. And then I've got 10 hydrogens here, so I'll put a 5 here. And then for oxygens, I can see I have 8 O's here plus 5 more, so there's 13 oxygens in the products. I need 13 in the reactants. Here's 1, so I'm going to need 12 more coming from here, so I'll put a 6. 6 times 2 is 12, plus 1 more, 13 oxygens in the reactants and in the products.